radiation view factors, as I said before, we have this problem where if you're a surface, it's easy to understand what that surface is emitting because you just need to know what the temperature of the surface is and what its properties are. If you're absorbing as a surface, you don't always know, it's harder to figure out exactly what's hitting you because you have to look at not just what other surfaces are around you, but are they actually facing you? And what field of view do they have compared to where you are? So that part of the problem that says, how much of the field of view does a given surface share with another surface? That's called the view factor. So just to define this a little bit, let's say we have a surface, surface here. We have a surface, we'll call this surface I. And surface I is emitting radiation. And over here, let's say we have another surface. Let's call this surface J. The question is, how much of the radiation from I is going to make it to J? And keeping in mind that surface I, when it's emitting diffusely, right? It's the black surface, it's emitting all over the place. So some of that radiation is eventually going to go and hit J and be absorbed, right? But much of it is actually not going to be. Much of it's going to go out and be lost to space. So only a fraction of the light that's leaving I is actually going to end up hitting J. So when we talk about this, we call this the view factor. So view factor, and view factor is defined as F I comma J. And so that's going to be radiation leaving I that hits J, right? And it has to hit it directly. This is the way we define view factor. But it directly goes from I to J, as opposed to like reflecting off of something and hitting it. That's divided by the total radiation leaving I. So it's just a fraction of light that hits J compared to what's leaving I. So the question is, like, how do you evaluate these view factors? It becomes important for us to pin down these view factors, and for doing a multi-surface heat transfer analysis, we have to know, okay, this percentage of I is going to J, and then we can, based on the temperatures, do calculations of energy exchange. But we need a toolbox, basically, to get into how we actually evaluate this view factor. There's like maybe 6 ways that I've got here, so we'll just kind of list them off. You might be able to get to the first 1 or 2 here. So the first is inspection. The second is view factor library. We'll just call that library. Third is the view factor integral. Do I? Some of them, yep. I have 3 of them, so sorry to duplicate. These last 3 are not on the next slide. They're just starting. 4 is rules. 5 is the method of crossed and uncrossed strings. And 6 is Monte Carlo. It's the Monte Carlo technique. So we're going to talk through all of these actually in the coming lecture or 2. With the last 2 minutes, we can start probably with with these here. These go pretty fast. So inspection is kind of what it sounds like. So you just look at the problem in front of you and you say, yeah, based on this problem, I know what the view factor is going to be, right? And so you'd say, I don't know, let's say we have a circle like this, and we have another circle like this. This circle here, okay. So let's say this is surface 1 and this is surface 2. What can I say about the view factor? Let's list these out. So what can I say about the view factor from 1 to 2? Just by looking at this. So imagine this is a cylinder, right? in and out of the page infinitely. What can I say about the view factor from 1 to 2? How much of the light emitted by 1 is going to hit 2? Yeah. So F1 to 2 is 1. All of the light emitted from 1 is going to hit 2. What does that say about F1 to 1? Can any of the light emitted by 1 hit itself? No. 0. Okay. So what about this? What about F2 to 1? Can I say from inspection what the light that's emitted by 2, can I say that anything about that in terms of, can I say anything about how much of that goes to 1? Not quite, actually, because think about this, right? So light that's going here, it could hit here. It could also miss and hit itself, right? And so depending on the diameter of this guy here, it might be something else, right? So you actually don't know. So don't trick yourself into thinking that by inspection, I'm saying this is true when it's not, right? It's really easy to fool yourself into inspecting something that doesn't actually exist. So that's inspection. Let's leave it there. So we're at time. We'll continue talking about these next time, including libraries and integrals.